Welcome to the module Nothing But Number Lines. In this session, we're going to look at how number lines are used across Common Core at the K-5 level, and we're going to look at some tips and strategies for building number lines into your classroom. Our expected outcomes for today are to understand the importance of the number line, to start understanding some strategies that we can use in K-5 mathematics, and then to explore some resources for the K-5 math classroom. Let's start just by looking at what research says related to number lines and why number lines are so important according to Common Core. Research suggests the importance of the number line as a tool for developing flexibility in mental math, for constructing meaning in mathematics, for developing number sense, for understanding number relationships, and developing strategies for addition and subtraction. The number line can do much more than just help children count to 100. It can be also used for a tool to operate on numbers. The number line is a powerful visual model for adding and subtracting. So this just means that this one single tool can focus on so many different areas for math. In the past, with past curriculums, we've had to introduce several different tools and strategies for each different concept or skill that we discuss with students. But the neat thing about the number line is it can be used across the board with so many different concepts. That's why the Common Core pushes it as early as kindergarten, first grade, primarily first grade, because it will be an essential tool all the way through middle school. Let's go ahead and just take a minute to think about all the different skills and concepts that the number line could be used for. At this time, you can pause the video. If you have other teachers in the room, you can take turns rally robin some different concepts and skills that you can use with the number line. If you're alone, you can just pause the video and take a minute to think about some of the different concepts and skills. Hopefully you've had a chance to pause the video and brainstorm some skills. I'm going to share the skills and concepts that I had thought of when I think of the number line. As you can see, the number line can be used in a ton of different areas of mathematics. It can be used with our MD standards, our OA standards, and our NBT standards. So this one tool could be used in so many different ways. The number line is a pictorial tool or a more representational tool. There's a couple different types of tools that we have within math. Some of them are concrete. Some of them are drawn or pictorial, and then some of them are abstract, such as like mental math strategies. So today our focus is going to be on that pictorial representation of the number line. There are two types of number lines that we will encounter with Common Core. There's the fixed number line and the open number line. The fixed number line is what you see here, where the numbers were already written for the student, and then the student just has to move or count the hops. An open number line is just a blank number line, typically that the students themselves would draw. This is a more flexible tool because the students can use it in a variety of ways. It does not have to have every number written on it, starting with number 0. This is more if students are adding and subtracting. For example, if they were adding 37 plus 24, the students might start by writing the number 37, and then they would count on and just write the numbers that are relevant for that problem. Let's talk a little bit about what the research says related to K2 number lines, or number lines at the K2 level. You will notice that with Common Core, they really start focusing on number lines in first grade. That's because research shows that number lines are very abstract at the kindergarten and still at the first grade level, and they're not typically recommended as a problem-solving tool at the K1 level. You'll also notice that in first grade, when number lines start being a focus, it's more of a very concrete tool just for very basic counting and problem-solving. Like I said, number lines are very abstract to the K2 students, and that is because students typically focus on the lines that are drawn on the number line, or the dots, rather than understanding that measure of space or counting those units or those hops on the number line. When we start working with the number line with students at the K2 level, we need to start by thinking of the number line as a ruler, where we are counting those units of space instead of the dots. In a couple slides, we're going to look at some activities to develop this understanding. Students at the K2 level, they will need to have ample experience just doing basic counting on the number line and solving really simple problems just to get acclimated to the number line. The exciting thing is if we can get K2 students to really use that number line flexibly, then when we get to third grade, the number line will be a really familiar tool to students. So when students have to start learning fractions on a number line, that unknown concept of fractions will at least be taught on a familiar or known tool, which is the number line. Just a little bit more research related to the number lines in the K2 classrooms. When we do start using the number lines for problem solving in first and second grade, the problems should be very basic, and they should be focusing on that part-part-whole relationship. So for example, if you have two parts and you combine those parts on the number line, what would be that whole quantity? When we typically focus on part-part-whole relationships and using models to solve those problems, research says that we should really focus on having one part look different than the other part. So even when you're combining these two parts to get the whole amount, students can still see those two parts separately. I'm thinking specifically of this third example in the illustration. Even though the students are combining two different parts, the parts are different colors, so when they're counting the whole, they can still see that those were two separate parts. So when we use number lines to represent those part-part-whole problems, we should try to help the students still see the two separate parts even when they're being combined to make a new whole. One suggestion for this is just drawing some hops or some loops to show here's a part, and when they're combined, here's the whole amount, and really emphasizing that arrow to show the big hop, that one big hop versus those two small hops. This has to be very concrete and very explicit to students. So some early experiences that we can do with K1 or K2 students just to get them acclimated to the number line, just get students to start counting up or counting down in the number line. Just do some simple things like +1 or one more and one less, just to see what it looks like to do that one extra hop or that one hop backwards. When students get acclimated to the one more and one less, then going to two more and two less. And then there's a couple other activities that we can look at, and we'll be taking a look at those across the next couple slides. So here's the guess your number or guess my number activity. This gets students to start thinking about magnitude or the size of numbers. Van de Waal says that all people have an internal number line where they can envision the size or the magnitude of numbers. This activity helps students to develop their internal number line by thinking about where numbers fall on that number line. So you would say to students, I'm thinking of a number 0 through 100, or if it was kindergarten 0 through 10, guess what my number is. And I would draw a little stick to show where my number is on that number line. Students might start by saying 21. I would draw where 21 is and say, no, it's greater. They might say then 38, and I'd say, no, it's greater than that. Then they would guess another number, and they would keep guessing until they get closer and closer. And this also builds that concept of greater than or less than. Another activity that we could do with students is making 20, or if it was kindergarten, making 5 or making 10 on the number line. You would show students that here is 20, and if I have 10, how much do I still need to make 20? Well, I would need 10 more to make 20. I would show the students another jump. Here I'm showing them 11, and then I would ask students how many more would I need to make 20? Or I would show them I have 12, how many more do I need to make 20? This starts developing those number relationships, but it also gives the students an opportunity to start thinking about how they can use a number line. So when they are later in second grade or in third grade, this becomes a really flexible, easy tool to use. So here's a first grade example of how students can start to use the number line to add some quantities. Here they are adding 4, 5, and 6. So this is an open number line. The students start by doing a jump of 4. and then they do their jump of 5 to get 9, and then they have to add 6. This student decided he was going to add 1 first to make that 10, and then do another jump of 5 to get a total of 15. Some students might be this flexible in their thinking. Some students might just do that other jump of 6, and that's all right. At first grade, we just want to start them to be exposed to that number line, so it becomes this really familiar tool by the end of second grade. Here is a second grade example using the number line for a simple addition problem. Here it says there's 37 people at the playground, 23 more show up. How many are there total? So we start by just writing the number 37. This student does a jump of 3 first because he knows that will make a nice easy number to work with, so he gets to 40. And then he does his jumps of 10 and 10 more. This is a really nice way to solve addition problems without having to regroup too. Students really see what it means, what that number 23 means versus that standard algorithm of just regrouping. This is a really great smartboard activity, or you can use this as an independent activity with your students, kind of building on that last problem that we saw with the student using the tens to add a number. If you go to dreambox.com/teachertools, there's a couple different number line activities there, and it takes a little bit of getting used to navigate, but it's a really neat tool once you get used to it. Here's another example of a second or third grade addition type problem that you can use the open number line to solve. I like this way because it's making a friendly number, and when I add in my head, this is how I actually do it. And I think a lot of students might start to do it, to add in their head this way once they are a little bit more fluent with addition and subtraction, but we can start off getting students to think this way by showing them what it looks like on the number line, and then eventually move away from that number line and more into that mental math. So 36 plus 29, I want 36 to be a friendly number, so I start by getting it to be a friendly number by adding 4 of the 29. I get to 40. Now that means I only have 25 of my 29 left, so let's do a couple hops of 10. There's my 20. So now I only have 5 left to add, and there is my total of 65. Now this might work well for some students. This might not work well for all students, but it's a good tool to introduce, and it does lead nicely into that mental math. So showing students how that mental math works by making a friendly number. Here's an opportunity for you to try a problem like this. If you want, you can pause the video at this point, and you can add these two numbers using an open number line. When you are solving addition problems with your students, there's a couple questions you want to make sure that you ask students. For example, does our number line have to start at number 1? And the answer is no, it doesn't. You can start at any number that works for you. And this is really important to talk about with students because a lot of times they feel like they have to start right at the beginning by writing 0 or 1 first. Does a number line have to have every single number marked on it? And again, the answer is no, because open number lines only have the numbers that are relevant to that specific problem. If you are solving a problem and you're trying to get the students to start, you could say, what could we begin with to solve this problem? And typically you could start with, if it's addition, just start with the bigger number and start by putting that number on that open number line. And then you could also ask students if they're having a hard time starting, what are the increments or the jumps that we can use to move on the number line? So after getting to that friendly number, a lot of times students are most comfortable moving by jumps of 10 or jumps of even 20 or 30 or 100 even. Here's another tool that is on dreambox.com/teachertools. You could just scroll down once you're there and look at this subtraction tool, and this is how this is one way that you can subtract using the number line, and it's talking about constant difference. What this means is that this problem right here, 197 minus 116, that's a really hard number for me to work with. So I'm going to make it an easier number by making the 197 200. So I added 3 to the 197 to make it 200. So I'm just going to add 3 to the second number to make it 119. But that makes it easier to subtract. The difference is going to be the same because both numbers, or both problems, I guess, are equally spread apart. So 197 minus 116 is an equal distance from 200 minus 119. It's just that those numbers are a little bit easier to work with. And now I can easily see that the answer to this problem is 81. Again, that is a really abstract concept for kids, and it takes some practice, but this tool is a great tool to practice doing that. And again, this leads into that mental math of us naturally just thinking about, okay, well, what is 200 minus 119? Another way to use the number line is to think about double number lines. For example, if you are looking at problems that have two different students in them, you might want to have a separate number line for each student. This problem here says Joey ate 2 donuts each day for 2 weeks, and Sam ate 5 donuts each week for 2 weeks. So how many donuts do they eat together? So this first number line shows me how many donuts Joey ate. This second number line shows me how much Sam ate, and it's then easy for me to figure out how much they ate together. Or if the problem even said how many more donuts did Joey eat than Sam, it's really easy for me to see that difference then. Here is one more example of a double number line problem. Here again, there are 2 students being referenced in the problem, and a lot of times when we have 2 students doing 2 different things in the problem, it might be a good time for a double number line. After reading this problem, I'm going to give you a chance to pause and create your own double number lines to solve this problem, but I will read it aloud first. Melinda and Maggie had 5 weeks to save money for vacation. Each week, Melinda saved $7. Each week, Maggie saved $4. How much more money did Melinda save than Maggie? Go ahead and pause the video, try to draw your double number lines to solve this problem, and press play when you're ready. Another way to use the number line is for multiplication. A simple problem such as 3 times 6 could be shown as 3 hops of 6. But the other thing that this nicely illustrates is that commutative property. Well, why is it that 3 times 6 is the same as 3 times 3? Well, let's look at the number line for this. 3 hops of 6 is the same as 6 hops of 3 because we will both have the product of 18. One question that you might ask students after solving this problem and then using the commutative property to solve 6 times 3 is ask them, will this always work? And have the students try to find other facts and then reverse the facts to see if this will always work where they get the same product. Another way to use a number line is for division. Here we have the open number line. The problem says if 8 plums are to be packed 6 to a bag, how many bags are needed? So we can start by writing 18, and then we could repeatedly subtract 6 until we get to 0, and then we could easily see that 3 bags are needed. I wanted to just quick show you a really good resource, LearnZillion. You've probably seen it at this point, but this video right here, a lot of their videos talk about common mistakes that kids make. And this video right here talks about common mistakes that kids make when dividing or multiplying on a number line. And the mistake that kids make here is that they typically count the number of lines versus the number of jumps, and then they incorrectly get the wrong answer. If you do show the video, start at the 1 minute point, and it will go straight to this common mistake here. Another way that we use number lines, this is more at the 3rd or 4th grade level, is for solving elapsed time problems. And again, this will be more of an open number line, but this is a really great tool for the 3rd or 4th grade level. Another thing that's worth showing kids when we work with elapsed time is what it looks like, what time looks like. I might actually show the kids 3 different number lines. The first one would be how many hours there are in one day. But then we can show students that anytime we zoom into one part of the number line, there's actually more to see. So if I was zooming in on that first hour, there's actually 60 minutes within that hour. So when you get close, you can start to see more parts to that number line. But then you can go even further and say, okay, well, let's zoom in on one of those hours, or sorry, one of those minutes. And then we can even see that there in 1 minute, there's 60 seconds. So for each time we zoom in, we're finding that there's more parts of that number line. This is going to be huge because this is also relevant for fractions, because when we zoom in between any two whole numbers, there's going to be fractions of a number or decimals of a number. Speaking of fractions, I did want to mention that it's absolutely crucial that you have a number line in your classroom when you teach fractions. Even if it's not as large or as long as this number line here, to have something in your classroom, especially something that you can manipulate and move as you teach those fractions. This way, as you introduce each part of your fractions unit, you can engage more with the number line. For example, when you introduce benchmark numbers, you could post those on your number line and then label the words, or label those benchmark numbers with the words benchmark number. Or if you teach equivalent fractions, then you can post additional fractions below and label them as equivalent fractions. And here you can see that I just punched holes in the bottoms of my cards and then just labeled the, or then hung the equivalent fractions below. And then this way you would tell students that anytime a fraction falls on the same point at a number, on a number line, they are equivalent. One other thing I wanted to mention about the number line is that you don't have to limit it to just the numbers. I do a Smarties activity typically in 4th grade, and we talk about how a whole pack of Smarties has 15, so 1/3 of that pack might have 5 Smarties, and we would hang a baggie of 5 Smarties under the 1/3 point. There's a ton you can do with this number line. The last thing I wanted to mention today is measurement and line plots. Anytime students are seeing a ruler or a line plot or even a bar graph or coordinate grids in school, those are really just other examples of number lines. We need to make these connections for students because as we introduce these new concepts, we have to be referring back to that familiar tool of the number line. Everything needs to connect back to that number line so that they, even if they're learning something new, it's not too confusing because at least they have that familiar tool. So one of the concepts that teachers often ask me about is that line plot standard because it is so complex for students. Try to refer back to that number line. Try to refer back to that number line you have posted in your classroom to make this a familiar tool, even if it is a new concept. The last thing I'm going to say today is really if we can just focus on number lines at the K2 level and get students really familiar with that tool, make it a super familiar tool. When we get into those really hard concepts in grades 3 through 5, they will at least have a familiar tool that they can rely on every day for those hard concepts. I appreciate your time today. Have a good day.